Chapter 6, Scatterplots, Association, and Correlation. Scatterplots show the relationship between two quantitative variables. They can show patterns, trends, relationships, and the occasional extraordinary values. When the x value is time, it's referred to as a time plot. Now, a pattern that runs from the lower left to the upper right is a positive relationship, and a pattern that runs from the upper left to the lower right is a negative relationship. So the top graph here shows a positive association. So as x is increasing, y is increasing. The bottom graph shows a negative association. As x is increasing, y is decreasing. So when the points approximately form a line, then they're said to have a linear form. So this top graph shows an approximate line, so those data points would have a linear relationship. The bottom graph shows a nonlinear relationship, so the points do not approximately form a line, and that's referred to as nonlinear or curvilinear. Points that are tightly clustered show a stronger relationship between x and y. If the points are a swarm that seem to form a cloud and it's really difficult to determine a pattern or a trend, that's an indication of a weaker relationship. So the explanatory variable, also known as the independent variable, is graphed on the x-axis. The response variable, which is also known as the dependent variable, is graphed on the y-axis. So the response variable responds to changes in the explanatory variable, or you could say it depends on the value of the independent variable. So correlation uses the standardized coordinates, and I put the formula on here just for information purposes. Your calculator will do this calculation for you, and you're not going to be required to do this by hand in class. But the correlation coefficient, which is noted by the letter R, measures the linear relationship. So more specifically, the correlation coefficient measures the strength and the direction of the linear association between two quantitative variables. So let's look at a couple of these examples. So on the far left, we have R equals 1. Okay, so that's going to be a perfect positive correlation. If we have an R that equals 0.8, it's a highly positive correlation. An R that equals 0.3 is going to be a low positive correlation, and an R equals 0 is going to show no correlation. So remember, we had talked about earlier that if your graph goes from the lower left to the upper right, that's considered to be a positive relationship. So if you have a positive relationship, your R is going to be positive. So if we look over on the right side of the graph, or of the table here, your R equals to negative 0.3 is going to be a low negative correlation. R equals negative 0.8 is going to be a highly negative correlation. And an R equal to negative 1 is going to be a perfect negative correlation. Now, your R value can be any value between 1 and negative 1. There's just a handful on here for an example, but you could have a negative 0.5 or a positive 0.4 or something like that. But this just shows you the scale. If R equals 1, perfect positive, R equals negative 1, perfect negative, and then you have all the values in between there. Now, there are a few conditions for using the correlation coefficient. So the first thing that you want to look at is that you have quantitative variables. Okay, no categorical variables, they have to be quantitative. The straight enough condition, you want to look at a scatter plot to see whether it looks reasonably straight, because your correlation coefficient is the measure of linear association. So you want to make sure that your data is approximately linear. The no outliers condition. The outliers can distort correlation, and they can make strong correlations look weak or weak correlations look strong. So check your scatter plot for outliers as well. One thing I want to stress is that correlation does not equal causation. Okay, even if you have a very strong correlation between X and Y, that does not mean that X is causing Y. It just means that you have a strong association. You could have what's known as a lurking variable, which is a hidden variable that affects the association between the other two variables. So just be careful. Just because something has a correlation or even a strong correlation, it does not prove causation.